for coming. I'm indeed going to talk about markup. I'm very excited to be at the Voorhoede today because I'm a bit of a Voorhoede fanboy. I was here all day today and I heard all these conversations about front-end development because they have only front-end developers here. So that excites me because I am a front-end developer and I usually work with a lot of back-end developers around me, and we can be good friends, but we're different and we have different interests. One of my interests is markup. So that's what I'll talk about today. This is my website. I like to blog about these things that I talk about today. So some of that stuff is also published there. It's also my company. I'm a freelance web developer. I currently work mostly at Mozilla. I spend most of my week there. And then I spend some time at the city of The Hague as well, where I work specifically on design system and accessibility of that design system. So a lot of accessibility is involved in that. But today I want to talk about web components. And the interesting thing about us being here in Amsterdam is that they were actually announced first here in Amsterdam in 2011. Alex Russell took the stage in Frontiers. This was in Tuchinski in the city. And he introduced these first kind of ideas about web components that he had. Some stuff that he talked about was what is a component? And at the time, we made our own components, but they only existed by that they had a specific class name or some kind of attribute. And for him, that was kind of cheating. That was not real components. That was just things with class names. So he wanted something that was more native to the platform. And for him, that's lying to yourself. And the alternative that he came up with was custom high-level components. So a high-level component is something like a button element or a video element. We have them in HTML, and it's an element that you can just use anywhere, and it works in the browser. And then the custom high-level component is something that but made by yourself, custom, however you like it. So a couple of things. They come with their own HTML tags, so you can actually use them that way. They hide the DOM, so that's also like the video element that has a play button and it has a forward button, but the buttons aren't actually in your DOM. They're kind of hidden away. They're obfuscated. It's called a shadow DOM. And then they also have scope CSS. So these are three of the big features that he already talked about in his 2011 talk. I was there, but I don't actually remember attending a lot of the talk because I was volunteering at the time and I probably was all over the place, but I watched it again a couple of weeks ago. And it's definitely worth a watch because it has this kind of first ideas around web components and also kind of reactivity happening because he was manipulating this JSON object that actually then showed up in the browser, and it already worked at the time, which I thought was quite cool in Chrome only, but yeah. A couple of years later, I was at Edge conference in London. This was this gathering of web standards people and people from browsers and developers, all sorts of different people. And they talked about lots of things that were new on the web, and web components was one of those things. And I remember myself thinking, I like this idea of web components, but all these people work for really big companies. So I can imagine Google wanting web components because they have very big websites with a lot of visitors and they have a lot of budget and time. So for me, it felt like, yeah, that's something that Google can probably do, but can we do the same? I mean, built-in HTML elements are really good, like the video elements. It's awesome. It works well. It works in different browsers and it works on phones. And can we ever do that ourselves if we are not Google, if we have different budgets? I've kind of changed my opinion a little bit there because there are companies that aren't Google that also make their own cool components. There are also open source projects that do this. So yes, it's happening, and we are doing good quality things. One thing that was published around the time was the gold standard checklist for web components. So this is a list of things that you can look at when you're building a component. So it has things like flexibility and reliability. Is it usable? Also has a lot of accessibility things in there. So they were definitely concerned with quality. But then again, they were big companies, and I was worried about small companies. Now, a lot has changed since that time, because now this stuff actually works in browsers. And at the time, you'd have, I think there was Polymer or a first version of that, and that was what you would use to use web components. And now a lot of this stuff is actually in browsers, and I think Peter will talk more about that, how that actually works. They also get used on the web quite a lot. There's this blog post by Brian Cardell where he looks at some data from the HTTP archive, and he looks at which web components are actually being used. He calls them dasherized tags because all web components have a dash in them to recognize that they're custom. And he found that they are used quite a lot. There's about 4,000 different ones. And a lot of them are ad related, which he thought was kind of sad. A lot of them are AMP dash elements that display ads in Google hosted websites. But still, there are people using web components. Here in the Netherlands, ING is a big one that do this. If you have ING as your bank, you can look at their source code and you will see lots of web components happening there. Yeah, I want to talk about quality web components because I think the future-proof ones, they need to have good quality. And for me, that a big part of that is accessibility. So this is actually an accessibility talk. If you came for the web components, I'm sorry. So web components, accessibility is very common in the real world. We have these tactile pavements. I don't know if you can see it on the slide, but they are different stones that people who are blind can use to navigate the street. So it's easier to use the street for them. We have elevators in our train stations. This is in Rotterdam, where I live. And they build these elevators on every platform. And the reason they do that is because it provides access to more people to the train service in this case. It's used by people who are in wheelchairs, but it's also used by people with a stroller who have small kids or people with a lot of suitcases. So it has a lot of different uses. It's also very expensive, these kind of things. But we all kind of agree that this is good to have this in our train station so that, our thing works for more people. And web accessibility is a bit like that, but it's about making your app work for more people. So it's about providing access to your app to more people. A lot of people benefit from that. I took some statistics and they're very hard to find because they're different all the time, but these are Dutch statistics. So we have people who are visually impaired and blind and people who are hard of hearing. So there's all sorts of different people that benefit from a more accessible website. There's also people who are temporarily disabled. For example, if you broke your arm or if you're feeding a baby and you're trying to use your phone with one hand. There's all sorts of situations where you can benefit from a more accessible interface. It's super helpful if people have made it more accessible. So there's lots of things you can do on the web to make your thing more accessible. One is color. It's important to have contrast in color. So if you have black text on white text, that's more readable than grayish text on white background. Those sorts of things we can optimize for and helps people who are colorblind. Language is another thing. We do this a lot at the city of The Hague because people need to pay their parking fines and that kind of thing. And we want them to understand that they need to pay their parking fine. So if you have a fine at the city of The Hague, we call this a naheffing. And this is not something people associate with a fine, but it means fine, and there's lots of technical and legal reasons for them using this different word. But we spend a lot of time trying to get these weird words out of the website and use language that normal people can understand. And that's a thing you can do in language. And then code. Code is something you can optimize a lot for accessibility. Won't surprise you that that's probably what I'm going to be talking about most today, to optimize your code for accessibility. And the cool thing is, if we compare this to the elevator that I showed before, it isn't that expensive to optimize your code. And that's because the web is accessible by default. A lot of this stuff is already built into the platform. Those elevators weren't. They were built there and designed, and they have to be maintained by expensive companies. And on the web, it's a little bit easier if we know how to write accessible code. The reason is that it was invented as a thing that needs to be universal. So the context of the web is that it was invented at the CERN, a research institution, and they wanted to exchange documents at the time with a lot of different scientists, and they all had different weird computers and operating systems. So it was just very important that it would work for all of them. So universality is one of these basic principles that the web was invented with. The W3C, who make a lot of our web happen. In 1997, they launched the Web Accessibility Initiative, and since then, they've spent a lot of time in making their stuff more accessible. The web platform itself. Tim Berners-Lee said it's universality. It's kind of the main point of the web. Disabilities are important to an essential aspect of that. And you can see that the proof of that, right, in code. We have images, but we can also add alt attributes. If we have a photo of a key, we can also write that it is a key so that people who can't see it still know that it's a key. Or if we have videos, we can provide subtitles, and the platform will take care of showing those subtitles. So they will make sure that all the text is shown at the right time and that people can actually turn it off or choose different languages if you provide those. You can set a default. These are all things that are built into the web platform that we don't need to worry about. We just need to hire someone to make the subtitles, which is fine. We also need to hire front-end developers and content people. So yeah, this is all built into the web. And if we optimize code, we are usually optimizing for assistive technologies. And that's a word I'll be using quite a lot. And I'll be calling it AT because I find it a bit hard to pronounce this word. So AT is things like screen readers that are used for people who can't see their screen. So it translates what's happening on the screen to a voice, which will then talk to them and tell them what's happening on the screen. That's kind of the idea of a screen reader. And then there's other things as well. This translates what's happening on the screen into Braille in real time, so people can feel what's happening on the screen. We use this umbrella term because a lot of these optimizations, they work for all of these different things because you're using markup properly. They all understand what's happening. So the main thing we need if we're optimizing for assistive tag is actually semantics. And semantics is about what stuff is and what stuff means. And a word for me that comes to mind, this is from the philosophy of language, is an ostensive definition. Might sound a bit fancy, but what it means is that you define something by pointing at it. And this is maybe familiar because it's how we've all learned what everything is in the world. This is how toddlers learn what stuff is in the world. So we point at something. I have a 1.5-year-old daughter, and I tell her what stuff is. So I have these eggs at home, and I'll point at them and tell her they're eggs, and she'll be like, oh, great, they're eggs. She will then go to other eggs and figure out that they are also eggs. In cartoons, she now recognizes them, and in different books and all these sorts of things. So the act of pointing is really important there. We do the same for ducks. We have a lot of ducks around our house, and she recognizes all these different colored ducks. We have black and white ones, which she also recognizes. And the pointing is a very important thing. And what we need to do on the web is point at stuff as well. So Google launched this actually yesterday. They made it possible for screen reader users to actually get automated descriptions of images, so that alt attribute that I showed before might not be needed in the far away future when Google can just tell us what stuff is with artificial intelligence. This is something that's very far away from the assistive tag world. I asked a couple of people who work for AT companies, and they didn't think, and this is obviously anecdotal evidence, but they didn't think this would come to their tools very soon. So Google are working on it. Microsoft have an AI initiative as well. But a lot of the stuff, a lot of the meaning, we still need to put it in ourselves because we know best how our interfaces work. And it's super hard to guess for a machine, especially the very obvious stuff they usually miss. So accessible code points machines at what stuff is. A bit of a story about that. So when you send markup to a browser, it's going to generate trees for you. We all know the DOM tree, so you send markup and it generates this tree. Everything in your markup becomes an object, and you have methods and properties and all these sorts of things. We probably all know this, and we work with this every day. But there's also an accessibility tree, and that contains all the accessibility-related information. So it's stuff like roles and names and properties. So a role is what kind of thing something is in the page. So this thing is a button, this thing is a header, this thing is a footer, here's the navigation, all these different things. So this is how we describe what something does in the page. Then there's names. They are things like if you have a link that says click here, that's the name of that link. So everything in that accessibility tree has a name, or it should have one. We'll get into that in a bit. And states and properties, so other things that we need to know about the component. This is an example of an accessibility tree that has a couple of things in it. It's a form. It has a radio button and a slider and another button. And all of these things have names, and they have some actions as well. The slider, for example, it has a minimum and a maximum. It also has a current value. So these are all things that get stored in the accessibility tree. Funny thing about this is, I think, that by looking at this tree, you can probably generate a picture in your head of what this could look like. It could look like a lot of different things, but for accessibility, it just has to look like that. So it's the raw data behind your component, and this is to tell assistive technologies what's happening with your component. So we have these assistive tag, and they need to figure out what's happening on your screen to tell your users. And the way they figure this out is by accessing platform APIs. So they sit on your platform and they understand everything that's happening on the platform. They know what your start bar is on Windows or the dock on the Mac. They know what a search button is in your browser. But as soon as you access a website in your browser, they encounter something that they've never seen before. So they need to rely on something else than just the platform API. So they need to look at this thing. That's where the accessibility tree comes in. It tells the AT ultimately what's happening on your page. And that's cool. I told that before. It's based on a DOM tree, and that's based on our markup. So this is where we come in. It doesn't really matter where we write that markup. If we do that in plain HTML and just upload it via FTP, or if we have some framework, we have a render function somewhere, or JSX, it doesn't really matter. We write our markup somewhere, and ultimately it ends up in the AT. And this accessibility tree is based on what we do there. That's why I focus on that in this talk, because we can actually make a lot of improvements there. If you want to look at the accessibility tree, which I presume by now you might want to, it works actually in a lot of different browsers. So you can open accessibility panels and actually view this information. It differs a little bit per implementation. So in Firefox, it's a dedicated tab where you can see the whole tree. In Chrome, you can get a different tab with the DOM tree. I think in Safari, it even works slightly differently. So whichever one works for you, you can inspect this tree and see if everything computes properly, because it tries to figure out what's happening in your page, and sometimes it fails. So by now, I hope it makes sense. The markup that matters for accessibility, at least. There's a couple of things that people want to figure out, right, if they come to a page, and especially if they can't see it. One is, well, what is this page? If you can see the page, you'll probably just look at it and maybe scroll through from top to bottom. But if you can't see it, then you rely on different things. And that's where this title element comes in. It's actually really important. It's a really old thing. We all know it, but we rarely touch it because it is there in our site, and then we work on it for another year, and we never look at what's happening in this title. But this is how people identify which page they have ended up on. So Leonie Watson made this video. She's blind and a screen reader user. She made this video where she showed what she's doing when she opens a website. And for her, the title is actually super important because it identifies that she's come to the right place. She may have followed a link somewhere or gone to Google. She ended up on a page, and she just needs to know that she's on the right thing. So that's what a title does. It's something we often forget about when you make a single page app. By default, it might not change the title when you do client-side routing, for example. So that's something to worry about. Make sure that title always reflects the actual page that you're on. Then the contents of the page. Headings are very important for that. So when you can see, you might use headings as well, right, to browse a page. But for assistive technology users, it can be a way to navigate for them. I've been told that this is one of the most used ways for IT users to navigate the site. So what they'll do is they will pull up a menu when they're on a page. So I'm on Wikipedia here, and they pull up the menu in their screen reader that has these headings. So this is actually all the headings that are on the page, and they get to choose from the headings. So it reads out all the headings first, and they don't see anything else or hear anything else. So for that reason, it's really important that we make sure that the headings actually make sense, and that we don't try to be funny. This is an example from Volvo's website. So they have this heading that says every detail counts. And does anyone want to guess what section this refers to, or where you would end up if you follow this? No. It's not. No, it's not the interior. It's actually the specifications page. So if you look at that visually, it probably makes sense because it has this big table with lots of information in it. But if you have to use that header menu and you just hear this spoken to, every detail counts, you might not choose to go there. You might not want to look at the specifications, and maybe Volvo wouldn't sell the car to you. Header hierarchy is another thing that's important when you work with headers. And this is the idea of that you can't skip heading level. So when you have heading 1, you can't just go to heading 3. You need to have a heading level 2 in between. This is a bit like a book. If you have a book that has a chapter, 3 and a paragraph 3.5, it wouldn't make sense for there to be no chapter 3 if you have a 3.5, because that would kind of be lonely. It wouldn't have a heading that it falls under. So there's no hierarchy if you skip heading levels. There's a cool thing for React that the people behind Tenon, an accessibility testing tool, made. They let you have this heading automatically. So you can have a heading component that you insert anywhere, and then it will automatically give you the right heading level so that you don't need to worry about it. Because this can be hard when you make components. If you make a component, you don't necessarily know where it's going to show up in the page. So if you have a heading in your component, you don't know what to choose. If it's going to be an H2 or an H3, you don't know where it's going to go. Another thing that's useful to figure out what's on a page is landmarks. They are also built into HTML, and they let you specify sections in a page. So all these elements are landmark elements, the header, footer, nav. So it's important when you use them to realize that what you're introducing to the page is a new landmark. So a screen reader user, again, has this menu where they can pull up all the landmarks. So if you have 1,000 articles on a page and they all have a header element in them, you're giving the user a lot of different landmarks, and it's going to be very hard for them to navigate it. So pick them wisely. You can set them with ARIA as well. But as Bruce Lawson said about this very subject, built-in beats bolt-on. So it's probably better to use the HTML elements for this, if you can, because they come with the roles built in already, and the support is quite good for that. Then one of my favorite things is form controls in a website. They're quite hard to get right and get the accessibility right off. So I'm going to say things that are maybe basic to some people, but they should be very useful still. There was this research done by WebAIM. They are a consultancy, I believe, and also a website that has a lot of information about accessibility. And they did research amongst 1 million websites. They call this the WebAIM Million. And they figured that 60% of all the form inputs weren't properly labeled. So I'll just show you how labeling works and why it's important. So in a form, you want to label input fields, radio buttons, checkboxes, select, all these different things. And the reason is that then they have a name in your accessibility tree. So they show up somewhere, and they then have a name that we can refer to. There is an example. I have this first name field with an input right behind it. And if I look at this in the accessibility tree, I'll get a role of something, text box or entry, depends on the browser you use. And then the name computes to null or to the empty string, because it has no name as far as the accessibility tree is concerned. So it has a name here, you might think, but it doesn't read that out when you go to that input. And there's a quick fix for that, which is to add a label. So these things get computed. There's a spec, actually, the accessible name and description computation spec. This describes exactly how names get computed. But the thing to remember is probably that everything just needs to have a label. All these other things can also give it a name. But the label is the best supported and the most old school thing. So the way it works is you have a label element and an input element, and they need to have the same value. So the label has a for attribute that refers to the ID in the input. And as soon as you do that, you will see in the accessibility tree that it now has a name. This first name just goes into the name value for the accessibility tree. And tables, we've been told don't use tables, but tables are very useful for displaying data. They make it easier to navigate for users of AT as well. They have a lot of stuff built in that helps them navigate, like look at this row or look at this column. So they are a pretty accessible thing as long as you don't use them for layout. A lot of people have been doing that, and for that reason, Assistive Tag has stuff built in to recognize if your table is a layout table or a data table. And the main thing to take away from this is to make sure that it gets recognized as a data table. And the way to do that is by adding table semantics. At that point, the AT will think, okay, that's definitely a data table, and it will treat it as such as well. So one thing you can add is a caption. For captions, they're kind of the name for your table. So someone I know works in an accounting firm, and he's blind. So when he would access these are two tables. It'd be really important for him to have an actual caption to sit on the table so that he can distinguish what the difference is between these tables. And then he will be able to find the tables faster. Because the alternative, if you're using AT, is to have all the table data read out to you and then try to figure out tell you which one is which. So if you add a caption, so I've done 2018 results and 2019 results, it's super easy to now recognize what the difference between them is. It's good to start with the unique thing first. So 2018 and 2019, they are the difference between this table. So whatever you put in the caption kind of determines how easy it is to find the table when you're looking for it with a screen reader. There's some other things like TH that you can add. They are headings for tables. And the scope attribute can describe if it's about a column or about a row. Those headings can go either way. Then language is another aspect of accessibility. We probably all know the lang attribute, which sits on the HTML element often. That's something that people don't always update when they make a multilingual website. It's something easy to forget as well. But with the lang attribute, if you specify the language, the screen reader can change its voice. So it can change from Dutch to English, for example. If you've ever driven in the Netherlands with Google Maps set to English, you will know that it will butcher all the Dutch street names. It's very hard to understand actually where you're driving. So a lang attribute would help there if it would have been built in HTML. So you can also specify specific parts of your website. So if you have a couple of words or maybe a whole section that is in a different language, you can add a lang attribute to it. And there's also another attribute, which is reflang. I only learned about this recently, but it describes what language the destination of your link is in. So this reflang attribute says that the link that I'm linking to, the page that you will end up in, is in that different language. Maybe this lets the screen reader actually load a new voice in time. And then if you use actually a Chinese word in this case to be the name of your link, then you can also set a lang attribute so that you have covered both the name and the destination of this link. And then another example is when buttons are just icons. People have different opinions about this. I've heard the opinion a lot that all the icons need to have labels next to them, but sometimes that's not feasible. So this is an example from Slack. This is with every message. So if all of these things would have labels, it would get really messy as an interface. So maybe it's defendable to have just icons there. This is the add reaction button, which we probably all know as the emoji button. There's lots of ways you could build this. This is one way. So you could make a div where on click you do the emoji thing. But what you'll see in the accessibility tree is that a div doesn't have a role and it doesn't have a name. And one problem that would create is that when you use your keyboard, you can't actually access this thing. So this would not get read out at all by the screen reader unless you use some special command that will take you to there. But then you need to know that it exists in the page. So an easy way to fix that is to add the button element, just the native button element. And that will give this thing a role of button. It will also automatically give you keyboard access and focus styles and all these kind of things. So that's an easy fix. You add a button there. And then you want to ensure that there's also a name. And one way to do that with these kinds of buttons is to add visually hidden text. So for example, I've added the span with some text in it, so that becomes the accessible name. By default, that would be shown right here, but you can make sure it isn't shown to people who can see it. That's called visually hidden. So you do something like position absolute left minus 9,000 or something like that, and then it goes very far away. And no one can see it, but people can still hear it because it computes to be the accessible name for this button. And then one last thing to do in this setup is to make sure that this SVG doesn't show up in the accessibility tree. You can take it out by adding two attributes, the role equals presentation and ARIA hidden equals true. They are kind of doing the same thing, but in different browsers. They have different browser support. So it's useful to use them both at the same time so that you are sure that it's actually hidden away. And then there's a weird focus bug in IE11 where if the SVG is inside the button, you can focus the SVG. So to avoid that, you can add focusable equals false. That is not standard. So if you don't like doing stuff that's not standard, don't do it. If you don't want to support IE11, also fine. But this is a way to avoid a focus bug. And then you might end up in the case where there is no meaningful markup. I've showed a couple of examples where default markup that comes with web standards, that is baked into HTML, gives you good accessibility. But sometimes you don't have that and you really want to make your own thing. In that case, ARIA can help. ARIA is a polyfill for accessibility for semantics that you can use. It consists of attributes that help you to give something a name or give something a role, properties, all these kinds of things. So you can add them to a lot of different elements, also divs, but you can also add them to proper things like a button. I have two caveats with ARIA. One is that usually there is existing HTML for your problem. So a button is a perfectly good example of that. In many cases, your custom component could still use a non-custom button to solve button kind of problems. So if it's something that you can press and that does an action, you can still use the button element inside your custom component. And then you get all those semantics for free and also the keyboard accessibility. So all these things come for free with the button. And also, not all ARIA has good support. This is a big problem with ARIA, that people use too much of it. Because it's really easy to find examples of ARIA on the web. But it's not necessarily true that when you put a lot of ARIA in your component, that it becomes more accessible. When I talked about this with some accessibility auditors, they told me that a lot of sites these days, they have too much ARIA. So they provide a lot of meaning and a lot of attributes that confuse the people that use it. So ARIA can be dangerous if you use too much of it. It can also be dangerous if you assume that it will work and the browser doesn't have support. That also happens because there are a lot of attributes and not all of them are built into browsers yet. And usability can be an issue. So something, for example, like a tab panel, there could be users that don't understand what a tab panel is. So it works as a tab panel, but if you don't understand how tab panels are used in your technology, then it's not a useful thing for users. So the best thing with this is to test it with real users, and that's hard. It's hard to find people for your test panel who have impairments, but that is definitely the best thing you can do. And the second best thing is to find blogs of people who use assistive tech and who explain how it works for them. So someone like Leonie Watson, she shares quite a lot about how she uses the web with her screen reader. And yeah, these kind of blog posts can help. And yeah, there's a lot of information out there, but be sure to research your ARIA. I have two examples of ARIA that I know works quite well. One is expendables, so something like a tooltip. There's some ARIA you can add for that. So in my example, there's a button that is this question mark, and there's a div that has this information in it. You can associate this with ARIA controls. So you put the ID of the div in there, and at that point they are related to each other, and the accessibility tree understands that they refer to the same thing basically. And then the second thing you can do is set the expanded state. So this tells the screen reader whether this thing is open or closed. So ARIA expanded opens it, and then when you set it to false, it's hidden. This doesn't do the actual behavior; it just conveys the state to accessibility tools. And then you can do the hiding itself with CSS or whatever you prefer. Another thing that ARIA is useful for is announcements. That's something that the web doesn't have built into HTML. But ARIA offers it. This is an example. Maybe you've sent in a complicated form with some changes, and then you get this thing show up that says your changes were saved successfully. I recently learned this is called a toast. So this thing shows up and maybe it disappears after a few seconds. And you want to make sure that this shows up in the screen reader just as it shows up for your other users. And a way to do that is use live regions. A live region is basically a div like this one. You create it with a role equals alert. And when you have this and you put any content in it, it gets read out by a screen reader immediately. So imagine this JavaScript is executing just when the response comes back from the server. You find a div, or maybe you already know what the div is. You set some text content to it, and at that point, that gets read out to a screen reader. It is important that this div already exists in the DOM or in the virtual DOM. That also works sometimes, so you can test a bit with that. And of course, you can do this in any way you prefer. In your framework, you might just be able to set a flag for this content. But yeah, as soon as it gets into the DOM and it goes there, then it will get read out by screen readers. So that's cool. There's also ways to not use markup to create more accessibility, and that's where the accessibility object model comes in. This is a completely new proposal, and it is very much on the drawing board currently. So they figured out what they want to do. They've also figured out some ways, but it got rejected by browser makers, and they're kind of struggling and trying to create a new thing for it. But what I'll share today is a couple of things that they want to do in the object model, or short AOM. So the AOM is a JavaScript API that lets developers access all the accessibility information. So what you've seen is when you change your markup or you do stuff in the markup, it creates stuff in the accessibility tree. You can look at that in your DevTools, but what would be more awesome if you can actually do this through JavaScript. That's kind of what AOM wants to do. It wants to fill gaps in ARIA, and it wants to let you provide your own accessibility as well. And it lets you test them from JavaScript as well. So you can read stuff from the tree and check if it does what it needs to do. So semantics without markup is a cool thing. You can select an element and you can just set properties directly rather than updating attributes. So what is a voice is something that they call sprouting in the AOM document. So basically that would be a custom element that has a lot of different attributes. As someone who likes Vue, I don't really mind having a lot of attributes, but I can imagine if you try to take this element to somewhere else, it would be great not to have these elements exposed, but just have them built in. And that's something you can do with these properties. So you can make sure they're kind of hidden away and they are part of your component. It's also comparable to what the video element does. You don't get to see all the ARIA stuff of a video element. It gets hidden away. Just like in Shadow DOM, you can also have its accessibility information be some kind of implementation detail. It would work well for big companies because someone can do all the accessibility stuff and then everyone else can just use it without worrying about it. So it could be quite cool. You can do relationships without ID refs. So I showed a couple of examples where we use an ID to associate two elements with each other. And if you take that relationship with an ID, you have to come up with the ID. So you have to generate one or you have to worry about it. And with the accessibility object model, you'll be able to associate stuff in different ways, so in JavaScript directly. And that's cool for all these different ARIA elements, ARIA attributes, things like ARIA controls that I just showed, but there are a bunch of other things that use IDs and that would then use other means. There's also events from AT that they're working on. This has a bit of a privacy implication for people who use these technologies because it also means that trackers can figure out that someone uses a thing and that they're maybe blind and that they can maybe charge them more. Or there are a lot of worries from the AT community. This is this is something that people worry about, but it could also be super useful because you can integrate that with AT. One more cool thing that you can do with the accessibility tree is have non-DOM nodes in there. So for example, if you build your whole app on a canvas, it doesn't have a DOM, so there's no accessibility information for any of your stuff. But with this, you would be able to create a DOM tree for something that doesn't have, you create an accessibility tree for something that doesn't have DOM. So you can just make it up as you go along and provide everything yourself. This is probably quite an advanced use and something you would only do if you really want to have your component exactly the way you want. But this is an example that they give in the specification. So they have a spreadsheet and they set a lot of different roles on things that aren't actual elements in the DOM. And then the last thing that they work on is reading accessibility information from JavaScript. They put it last because it doesn't touch users as much as the other stuff. But reading accessibility information is useful for testing, for example. You can do this in your testing framework and then test if all the properties are properly set, as you would expect. That was pretty much it for me, but I'll give a quick summary. So quality future components, for me, they need to be accessible. I think that's very important because the built-in stuff is accessible. If we're going to make our own, then we also need to take that responsibility. The cool thing is that good markup already helps and it gives us a lot of this stuff for free. And if we really want to, we can also set it ourselves and convey what everything does without using markup or by using divs or something like that. So we can also polyfill it. So that's all for me. I have my information on slides on this URL. There's also the resources and stuff. And you can ask me questions on Twitter or now if anyone has a burning question.